Hey, welcome back and good morning. Hope you guys enjoyed your day off yesterday and got some rest, and we're ready to go again. Today we're going to kind of expand on inverses. On Monday we talked about how to find the inverse, whether that was through an equation or with a set of points. Today we're going to talk specifically about how to graph these inverses. So, just like what we did on Monday, when we start with the point x, y, the inverse of that just switches and becomes yx, okay? In the same way, today, we have our points here. So on this graph, we have the original function. There's 5 points here. And we want to just take them and switch them. So 6, 8 up there will become 8, 6. 1, 4 becomes 4, 1. Negative 2, 3 becomes 3, negative 2. Negative 4, negative 1 becomes negative 1, negative 4. And finally, negative 5, negative 4 becomes negative 4, negative 5. Now we have 5 new points, and all we got to do is graph these. So let's see. Alright, and then just draw in as straight a lines as you can. And hopefully you notice if you kind of turn your head to the side, obviously I made a little bit of human error right in this area, but it should look like a reflection over that line y equals x, which makes sense because our y's and our x's switch, so it will cause it to reflect over that line. Alright, so that one, they already gave it to us. This one, same idea, except now we need to name our points first. So the original function, they have points on it. We just have to figure out what are these different points. And once again, we're going to start in the function, which is xy, and everything will switch. The inverse, the y and the x switch. So we look here, and that first point, negative 3, 6. Then we have negative 2, 1. Negative 1, negative 2. The vertex at 0, negative 3. 1, negative 2. 2, 1. And finally 3, 6. And then each of these we'll just flip over and see what we got. So it can be a bit tedious, but it's not difficult. And then after we get them flipped, all we have to do to finish it out is graph our points. So 6, negative 3, 1, 2, 3, 4, 5, 6, down 3. 1, negative 2. That point already existed. That's fine. Sometimes that happens. Negative 2, negative 1. And then 0, negative 3. We go the other way. Negative 2, 1. 1, 2. And then 6, 3. We draw in our shape. And the one in blue is our inverse. Alright, so go ahead, after you got that done, flip it over to the back now. And the only difference on the back is sometimes we don't even have the graph of the function. Okay, so here, example 3 says graph the function of f of x equals 2x plus 3, then graph its inverse. So when that's the case, step 1, just graph the function. So, hopefully you guys remember y equals mx plus b. that is the case, this is our m, so m is 2 over 1. Our b is 3. Think of that as your starting point, right? So you go up 3 on the y-axis, that's the y-intercept, then up 2 over 1, up 2 over 1, or we could have gone down 2 and left 1. And that would be our original function. So step 1 done. Okay, step 2, we need to name our points. So we've got 4 points here. We know that first one is at, 2, 7 it looks like, and then 1, 5, 0, 3, and finally -1, 1. Step 2 is done. All right, step 3, we're going to flip the points. So x comma y becomes yx. So 2, 7 will become 7, 2. We get 5, 1, 3, 0, and 1, -1. We finally then, step 4, I kind of got a little ahead of myself, but step 4, we will plot the new points. And we're done. Now, since you guys probably don't have colors, if you want to make it a little nicer, you could put like an f of x here, f of -1 of x. That symbolizes that's the inverse. Those are nice labels, not required, but it might make it a little more clear. Now we got a couple more. This next one, it's a little more difficult than a line to graph, but hopefully we remember when it's x plus 2 in the parentheses, then we know it's going to shift left 2. So rather than starting at 0, 0, we know it's going to start here at -2, 0. So maybe you remember making t-tables, -2. If we would plug that in for the x, when I say plug it in, I mean plug it in right here. -2 plus 2 is 0. 0 cubed gives us 0. It could also go each way, so -3. If you plug that in, -3 plus 2 is -1. -1 cubed is -1. You could also go -1, because we want to go 1 on each side of the vertex. -1 plus 2 is 1. 1 cubed is 1. And then probably go 2 on each side. So let's plug in a -4. -4 plus 2 is -2. If we cube that, we'll get -8. And then so right there. And then the final one, if we plug in a 0, 0 plus 2 is 2. 2 cubed is +8. And then all we got to do is draw that. All right, now my points look slightly different. They're in a t-table here, but it's the same exact thing. So we're still going to just flip them. So instead of -2, 0, we get 0, -2, and down the line. All right, so 8, 0, -8, -4, 1, -1, -1, -3, and finally 0, -2. We draw that line in, make it as smooth as we can. And once again, if you kind of turn your head sideways, the diagonal there, they will reflect over it. If you're not sure what I mean, if I would draw this line in, they will reflect over that. Obviously my graph's slightly off, or maybe it was my line here. Should have went right through there, but that is a reflection over the line, y equals x. That will always be the case with your inverse. So, final one. On this last one, hopefully you remember, it shifts down 4 because of that negative 4 tacked on at the end. Inside the parentheses, if it's negative, that means right, so right 3. So rather than starting at 0, 0, we know it's going to start right 3, down 4, or at the point 3, negative 4. Now, some of you know when this has a quadratic, that's a parabola, you can use your 1, 3, 5 rule, so up 1 over 1, up 3 over 1, up 5 over 1, and then go the other way. If you don't know what I'm talking about, you also can solve it just like we did on the last one. All you'd have to do is plug in, work each way, plug in your values right here for that x. It's up to you on how you do it. So now we're going to write our points. So we have 0, 5, let's see, 1, 0, 2, negative 3, 3, negative 4, 4, negative 3, 5, 0, and finally 6, 5. So when we take the inverse of each of these, they switch. Once again, none of the signs change, just the x and the y switch places. And finally there, we draw that in, and let me undo that. That was not a good line. Okay, the final line here. All right, and we're done. Now, one thing I do want to point out before I let you guys go, so I'm going to switch over to Delta Math tab, and it's going to be a small Delta Math assignment. The first section, it says identify an inverses graphically. So to do this, it says graph the inverse of the provided graph on the accompanying set of axes. You must plot at least 5 points. Click the graph to make a point, click it again to erase. So for example, I can click here. If I decide I don't want that, I can click it and it disappears. Also, you'll notice this line, y equals x, it should reflect over that. So all we have to do is I recommend hover with your mouse. Maybe the vertex is a good spot to start. It matches up right there at negative 9, 4. So if we switch that, it'd be at 4, negative 9. Put a dot. Then let's find another one. You can find whichever one you think is easiest. So right here, this is a good one. It goes through the y-axis at 1, so that's at 0, 1. So that'll become 1, 0. This one is at 0, 7, so that will become 7, 0. It also went through the x-axis already at that point, 7, 0. So 0, 7 will also work. And then it's up to you. You can find whatever point goes right through an intersection. So here, negative 5, 2 will become 2, negative 5. And once we get that fifth dot, it puts it in. Now, let me show you, if you make a mistake, that doesn't match up. It puts the graph in, but it doesn't match up our points, so we know we did it wrong. But once I put it there, it matches up with all our points, so we know we did it right. And we can submit that answer, yes, and we see we got the check mark. And it shows you what you did if you want to see. Now, the other type of problem here, right here, is doing the inverse just like we did yesterday, it's multiple choice, just like we did on Monday. So it says for the function f of x equals x to the 7th plus 3, find f to the negative 1 of x. That's our inverse. Now let me show you how they do it. So the first thing they do, your original function, remember we replaced that f of x with a y. Then we always switch our x and y. They switch places. And then we just solve for y. So here, you're just going to subtract the 3 over. You'll get x minus 3 equals y to the 7th. Anytime you have an exponent, you can just do, like if it was y to the 2nd, we do the square root. If it's y to the 3rd, we do the cube root. If y to the 7th, we do what's called the 7th root. Okay, so we take the 7th root of both sides, and that will cancel out with the 7th, and we would be done. Okay, now since this is multiple choice, all we have to do then is choose that, and we can submit it, and there we go. We're done. So Delta Math should not take too long, I hope. Hope you guys have a great day, and talk to you later. Bye.